All right. How are we doing? Are you done? You need a table. If you want the table, please say so. I'll bring up the table. Anyone who's done? Right. We need to check on the solution here. We can't do this for more than 10 minutes. Anyone with a solution or done? People, talk to me. This is a tutorial class. Talk to me. I'm asking, are you done?
No, sir.
Hmm? You're still waiting?
Yes, sir.
Okay, that's better. Thank you. 3 more minutes. Okay, let's get the solutions to this. Let's get the solutions. Let's get solutions. Okay. Okay. This is so slow now. All right. Let's put up the null hypothesis. The mean is 10. So
It's greater, sir.
greater than, thank you. And we're testing at alpha, how much percent? 1%. So it's 0.01. And the test statistic, it is a Z distribution, is X bar minus the mean over that over root N. And X bar is 11. Which 6 over root sample size 35.479. Did you get this?
Yes, sir.
Now we're doing good. Then it is a one-sided test, so it's Z1 minus alpha. And that's equal to Z1 minus 0.01 is equal to Z 0.99. And 0.99 from the tables should give us 2.32. Or one can say 326, or one can say 2.33. You got this?
Yes, sir. I got 2.33.
Perfect. That is perfect. No. Then it's step number 5. Is what? Is less than 3. Null hypothesis is what? Is significance. What's wrong with my pen now? The mean. Oh. Nice doing things now. Come on. The mean response time. The mean response time is not greater than 10 minutes. There we go. There we go. You got this one right? Then we can move on to the next one. Number 2. Let's move on to number 2. 2. Right. Quantitative methods marks of students are known to be normally distributed. After 800 first-year students who have taken 15 of the test scores are drawn at random. Significance, whether the average quantitative method mark is different from 60. Now, you know, in a calculation, you need the standard deviation and the mean. They are not given. So you're going to have to work the X bar, but I've given you the standard deviation as 15,54. Use the 15,54 as a standard deviation.
All right. How are we doing? Right, let's get solutions. Are we done? Are we done? People,
2.602. That is correct. All right. So our t value is 2.602. We're going to use this in our problem to finalize the problem. All right. So this is 2.602. Right. So that's our calculated value, our critical value. And we can see the calculated value of command 9168 is less than the critical value. Therefore, at step number 5, the null hypothesis is not rejected. It is accepted. The null hypothesis is not rejected at 2% level of significance. Good. Then we can conclude the average quantitative methods mark is not different. Is not different from the 60%. Done. So here you had to work out the sample size as well as, not the sample size, sorry, the mean and the standard deviation. But I gave you the standard deviation. Had I not given you the standard deviation, you would use the equation for ungrouped data to calculate the standard deviation, which is the sum of xi squared minus x bar squared on n minus 1. You see, that's why it carries 8 marks. You'd have to use this in order to get this answer. Okay, let's move on to number 3. We have only four questions to do and we'll be done. So we go to number 3 now. Let's bring in up number 3. Number 3. Here is number 3. A study commissioned by an insurance consultant shows that 40% of those people involved in minor traffic accidents this year have been involved in at least one other traffic accident in the last 3 years. That's just a statement. An analyst decided to investigate this claim because he believed the indication should have been smaller than the reported 40%. A sample of 200 minor traffic accidents showed that 74 people were also involved in other accidents within the last 3 years. Test this claim at the 1% level of significance. Just to give you a clue, this is all about a proportion. This is a hypothesis test for a proportion. Please give it a try.
Right, any progress? Are you done? Okay. You got to look at this. We no longer have so much time. Let's get to the solution for this one. Right. First thing that you want to check on is your proportion. And your proportion, that is your P. The P capped is 74 over 200. And that gives you a 0.37. All right. Then let's start now with the null hypothesis. Proportion is equal to 40%, which is 0.4. The alternative proportion is what of 0.4? What do I write in between here?
Less than.
Less than. Perfect. Perfect. Less than. And the alpha is how much? 1%, 0.01. Now this less than, people, it comes from that statement. It said, an analyst decided to investigate this claim because he believed the indication should have been smaller than. There's your less than. All right, a statistic. This is a Z distribution, and we know it takes P capped minus PO, or remember, some may use this over the root of PO into N. And this is equal to 0.37 minus 0.4 over the square root of, somebody please mute your stuff, 0.4 into 1 minus 0.4 over 200. And this should give you 0.87. You got this? Did you get this? 0.87?
It's not negative.
Negative, yes. You are right. Correct. Negative, that is correct. And therefore, step number 4, it will be negative Z 1 minus alpha. Thank you, sir. So it's negative Z 1 minus alpha is 0.01. And that means negative Z of 0.99, eh? And that becomes a negative 2.326, or you can say 2.33. Now, remember something, people. We said when you read your critical values from the table, supposing you had forgotten this negative, you have forgotten this negative, so you just come to 2,33. You just come to 2,33. But because I had a negative here, where did it vanish now? Because your answer here is negative, and you want to do a comparison at step number 5, this must also be negative so that we compare apples to apples. We've been saying this. All right, so let's see. Since what is the calculated value? Negative 0,87 is bigger than negative 2,33. HO is what? What do we do with the null hypothesis? Yeah, I always do my little diagram, then it gives me correct answers. The critical values, 2.33 here, and this side, negative 2,33, and I want to locate my answer. Negative 0,87 will come here, and it is in the acceptance region. Yes. Is it correct? Negative 0,87 is bigger than negative 2.33. This is correct, isn't it?
Yes, sir, it is.
It is. So, null hypothesis is what?
Is accepted.
Is accepted. Correct. It falls within the acceptance region.
Yeah.
Okay.
Yeah, Gapar.
All right. Now, if this is accepted, then you can conclude and say, those people, let's try and write it in short here. Those people or persons involved in minor accidents have not been involved. Have not been involved in at least one minor traffic accident. Not accidents, in the last 3 years. In the last 3 years. Done. That is our story. Have not been involved in minor accidents in the last 3 years. Okay, let's tackle the last one. Let's tackle the last one. Let's tackle the last one, number 4. Right, here's number 4. With the increase in the price of petrol, drivers are more concerned with their car's consumption. For the past 6 years, a driver has tracked the petrol consumption of her car and found that the variance from full up to full up was 23 kilometers per liter. Now that her car is 6 years old, she would like to know whether the variability of consumption has changed. She recorded the liters from her last 8 fill-ups. These are listed below. Conduct a test at the 10% level to infer whether the variability has changed. Now we've given you the variance here. So here you're testing the hypothesis for variances, but I've given you the sample variance here as 16,5. Please use that for your variance, or for our sample variance. Right, how are we doing? Okay, let's check on the solution for this. Let's check on the solution. I know this one is a bit tricky, but let's do the solution. Okay. Now, this is the hypothesis test for a variance. And I said you are given the sample variance as 16.5. And you want to draw the hypothesis. One, hypothesis, null hypothesis for a variance. Variance is sigma squared is equal to 23. And the alternative variance is not equal to 23. We're testing at 10%, which is comma 1. And the test statistic, it is a variance. So it is that chi-square equal to n minus 1 by the variance sample over the population variance. So this is equal to, what is the sample size? 2, 4, 6, 8. So it's 8 minus 1 by 16.5. 16, we don't square it because it is given purely that it is a variance. So you don't square it. It is already squared as it is. The population variance is 23. And if you work this out, you should get 5,0217. Then as step number 4, because it is two-sided, it will be chi-square. Remember, the chi-square has n minus 1 degrees of freedom, but because it is two-sided, the lower side, it will be alpha on 2. And this is against the upper side, chi-square n minus 1 and 1 minus alpha on 2. And this is equal to n minus 1, n is 8, so it is a 7 here, and alpha on 2. Alpha is comma 1 on 2, that becomes 0,05. And this is against chi-square here, 7 again, 1 minus alpha on 2 is 0,95. And if you check from the table, the chi-square table, you will find 2,17 this side, and this side it will be 14,07. Right. Now you want to see 5,0217. Where is it falling in this interval here? Because we can say we can have
the distribution like it is 2,17 and 14,07, and you can see 5,0217 is falling in between. So you can say this is as good as 2,17 is less than 5,0217 is less than 14,07. It is in between. And therefore, if it's like this, at step number 5, HO is accepted. HO is accepted at 10% level of significance. Now remember, the other day when we were doing this in class, we used a one-sided test. And the step number 4 was a bit different than what you're having. You must be very careful with this one. So we can't infer that the variability has changed. That's our story. That's our story. Now, what we've been doing here, you'll realize we started at number 1, where we're doing hypothesis for a large sample, where we applied the Z distribution. At number 2, it was a small sample, we applied the T distribution. At number 3, it was the proportion. And at number 4, it is about the variance. So we have done all what needs to be done for a hypothesis for a one population. Next week, we're going to be looking at 2 populations and see how do they differ with the one population. But the basic principle is the same. The basic principle will always be the same. Yes, and this is the end of it for today. And I want to thank you for connecting. People, you must start to practice this stuff, because remember now, in 2 weeks' time, around about the 11th, 12th of August, you'll be writing class test number 3. So you need to start to work on this stuff before it is too late, or before your work catches up with you. So this is it for today, for tomorrow. Now I want to ask you people, are you coming to class? Like next week, I've seen there was a notice to say all COVID signs and stuff must be removed and classes must be cleaned and so on. Do you have any idea as to whether you're coming to class or not?
Sir, today our maths lecturer also said we will be starting with contact classes next week.
Now that will be fine. I like it. I would love that one, because hey, these online classes are not too effective for me. All right, so we'll get confirmations. But yes, we got messages to say we are now on full capacity and classes are cleaned and all that. But it's fine. We'll get confirmations, and hopefully from next week we go back to class. Thank you so much, good people. And I'll see you again next week, hopefully in class. Thank you and have a lovely weekend. Goodbye.
Thank you, sir. Bye-bye.
Great.